we're going to solve the right triangle ABC if we know that side little a equals 29.43 and little c is 53.58. So this is a little different because we weren't given a side and an angle, we were given two sides, yes. Now interestingly enough, you have to be given at least one side or you can't solve it. But I'll always give you information that will allow you to solve it, so you don't have to worry about that. All right, so let's see what we have here. I'll call this C, and this is also little c, 53.58. And then I'll call this A, which means this will be little a, 29.43. And this will be capital B, so this will be little b. Well, the good news when you're given two sides is you can use the Pythagorean theorem to solve for the third. Always be on the lookout for that, okay? Do that first. It's the easiest thing to do. So we know that a squared plus b squared has to equal c squared. So 29.43 squared plus b squared has to equal 53.58 squared. Now, I hate writing down decimals, so I have a tendency to just like rearrange it before I type it all into my calculator. So I'm going to go ahead and rewrite this as b squared equals 53.58 squared, because you are not allowed to round during the problem. You're only allowed to round once at the final answer, so I don't want to type all those decimals in and then have more decimals. Minus 29.43 squared. Okay? That's going to be b squared. So I'm going to go and I'm going to type that in and write that down and see what we get. You guys should calculate it along with me to make sure that you get the right answer. I got 2004.6915. How do I find out what b is?
Square root.
Take the square root of both sides.
Square root answer.
Yeah, and if you know how to do that, that's the square root of second, yeah, second, usually negative, but it depends on what calculator you're using. So.
44.76.
And that gives me 44.77378139 centimeters. That is the unrounded answer. I want how many significant digits for this problem?
4.
Let's see, that has 4 and this has 4, so I need to round to the 4th. So I need to round it right there. So does it stay 44.77 or round up?
44.77.
Okay, that is what B is. 44.77 centimeters. All right. What else is missing?
Every single angle.
No, I know capital C. So I'm really just missing A and B. Which one do you want to find? A? All right, let's try to find capital A. I need to figure out a relationship between capital A and the two things I was given, okay? That's going to be a SOHCAHTOA relationship. That's the only one that involves angles, right? Sine, cosine, and tangent? All right, so I need to know how capital A relates to these guys. And those are the opposite and the hypotenuse, so that's how we know we're going to use sine. But I'm missing A. So I'm going to write down sine of capital A equals opposite over hypotenuse. 29.43 over 53.58. Okay. Anytime you're missing an angle, what do you type into your calculator? Second, and then whatever your trig function is. So you're actually going to type in second sine of that, 29.43 divided by 53.58. Okay? And that will tell you your angle, and we're going to round it to 2 decimal places. Well, maybe. I think so. We're going to round it to 4 significant digits. What'd you guys get?
36.68.
All right. Second sine, make sure you're in degree mode. Second sine, 29.43 over 53.58.
I got 33.30. I got 56.68.
I got 33.32.
What am I doing wrong?
I don't know. I'll look. Hang on.
You second? Yeah, second. No, I hit the wrong. I did cosine instead of sine.
Gotcha. Okay, did you guys get that? Okay, that's capital A. Now I need to find capital B, and there are two ways to do it. I can redo SOHCAHTOA, or what do the angles have to add to?
To do 90 minus the second answer, you just go.
Yeah, does that make sense? You guys understand that? But you have to use the unrounded answer. So you have to be really careful with that. So capital B has to equal 90 minus capital A. Okay? Which is 90 minus 33.31709144.
56.68
And we got 56.68.
68 degrees.
So you recommend doing that instead of SOHCAHTOA?
It really doesn't matter. I mean, as long as you don't
You can just
round.
second answer it if you just leave it.
Right. If you're comfortable with your answer button, you know, then it kind of depends. You're just not supposed to use a rounded answer to get another rounded answer. However, because they add exactly to 90, it's not as much trouble as it would cause as the Pythagorean theorem causes when you round, because it has so many decimals and whatnot, and these are kind of going to an exact value, which is nice. So it doesn't matter, honestly. I always, for the third angle, just do 90 minus, the one I know, because you're not going to get into a lot of trouble that way.
So you're really using the unrounded if you're doing Pythagorean theorem or doing 180 minus whatever.
Right. Well, you always want to use you always want to use the unrounded. If you're, let me try this again.
You're like subtract.
If you're using
I know.
numbers other than the two givens,
Yeah.
you want to use the unrounded. Like, you want to use whatever you got before you rounded. If you're not sure, go back and do SOHCAHTOA. Guys, try this. Tell me what you would get if you solved this equation. Cosine of B is equal to adjacent over hypotenuse. So 29.43 over 53.58. Do second cosine on that.
56.68.
Do you get the same thing, 56.68?
Do you want, say you want to avoid, the one you came up with, the third one?
Right, you would like to.
Yeah.
But a lot of people just do it anyway.
Yeah.
But it will occasionally give you a rounding error in your last significant digit. So you're supposed to be very careful about that. Because particularly physics teachers and chemistry teachers, will
They care.
pummel you on significant digits. And they do matter.
They're significant.
If we were actually doing a lab, I would understand. But
Well,
if we're doing numbers they gave
Well, the
us,
problem is that, you think about when the Challenger exploded. Do you guys remember that?
Yeah.
It was all over.
Rounding.
Basically it was because they weren't within enough, decimal places of accuracy for all those little O-rings there. And, the same thing with the Mars rover. It was, they weren't accurate enough, and the Mars rover couldn't get into Mars's atmosphere. So it does matter that you're very careful and that you pay attention to your significant digits, because those were really costly mistakes. The same thing with building bridges in civil engineering. So be careful, okay? I know right now you're thinking about it's just a triangle, but at some point in your lives, it could be other people's lives on the line. So you do have to pay attention to detail. So now we want to hop over and talk about applications involving angles of elevation and depression. You have to remember that the angle of elevation and the angle of depression are always measured from the horizontal line of sight. Okay, and if it's not an animate object and doesn't have eyes, it's just horizontal from the object, okay? So here, in this example, if I'm standing here, this is my line of sight. And to look at this object up here, I have to raise my eyes to see it, and this angle trapped right here becomes your angle of elevation. The angle of depression is different. Let's say I'm sitting up in a tree, okay? Yeah, I'm sitting up in a tree. This is the horizontal, and I have to look down, okay? Then this is my angle of depression. It's not weird until you see it in a triangle situation. Let me show you.
Why did they make it go
I don't know.
Even though
It's annoying, isn't it? Yes. That's why I darkened over it. Okay. Be careful when interpreting the angle of depression. Both the angle of elevation and the angle of depression are measured between the line of sight and a horizontal line. Got it? Not. Well, it's. Let me show you. Just look at an example, and then I think I can make it clear up. I will show you where people go wrong all the time. Okay. So your book wants to tell you that they want you to draw a sketch and label it with the given information. Then they want to label the quantity to be found with the variable. And your sketches should probably be what shape? A right triangle, since that's what we're studying right now, and that's the majority of trig. So somewhere you need to get a right triangle drawn and get everything labeled. All right? Then you want to use the sketch to write an equation relating to the given quantities. Okay? That will either be the Pythagorean theorem or a SOHCAHTOA equation. Can't spell SOHCAHTOA. Okay, SOHCAHTOA. Then you solve the equation and check that your answer makes sense. Please don't tell me that, it's negative 2.3 feet to the flagpole. Okay? All right, good.
For example,
So-
like casting a shadow and
Pat Porterfield, she needs a last name, so we're going to give her a last name Porterfield. She knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. If her eyes are 5.30 feet above the ground, find the height of the flagpole. Now, there's a lot going on in this problem, okay, so I'm going to help you draw it, but I also want to talk to you about this. If you are told how tall someone is, you use their height, because obviously my eyes aren't on the ground usually if I'm standing somewhere. You understand that, right? But if you're not told, you're not going to be very precise because you'll just assume they're on the ground looking up, and that's not usually the case. So if they tell you the height, you factor that into your problem. If they don't, you just don't worry about it. Okay, so here's what I have. She's standing on the ground. All right, let's let this be the ground. Here's the ground. Here's Pat.
Pat Porterfield.
Okay, hold on. Here's Pat. Pat doesn't have legs, but whatever. Okay, so there's Pat. All right. Somewhere over here, how far over here? 123 feet. There's a flagpole. Right? Yeah? Her eyes are here. So here's horizontal from her eyes. Do you see that? All right. To look at that flagpole, the top of it, she has to look to right there. The triangle in question is this one. There is your triangle, not the big one. She's not looking from down here. It's this one right here. That's the one she's dealing with. We'll talk about what else is going on in just a minute. How far is it from here to here?
123.
That one's also 123, which is good. Do I know how far it is from here to here?
No.
Do I know the angle?
Yes.
I know this is 90, right? Do I know this angle? 2640. Okay. Is that all I know? In the end, what do I want to find here? I want to find the height of that flagpole. Well, I already know this piece. How much is this piece? 5.30 feet. What am I missing?
The rest.
That piece right there, the rest of it, yeah. So could I just call that X? Do you guys mind? I don't like to use A's, B's, and C's if I don't have to, so I'm just going to call it X. That's what I'm missing. Understand? Okay. Could I use the Pythagorean theorem? Do I know two of the three sides? Okay, so I can't use Pythagorean theorem. So I'm going to have to use...
Don't you just have to do... No, you could...
Okay, so what could I use? If I can't use the Pythagorean theorem,
Tangent.
I could use SOHCAHTOA, right? So we have to decide whether to use sine, cosine, or tangent based on this information to find x. All right. Well, am I interested in the hypotenuse?
No.
No.
Yeah. If I don't care about this, if I don't care about the hypotenuse, it's not going to be sine or cosine, okay? It's going to be tangent. I don't know it, but I don't care about it, okay? I only am interested in the opposite side, and I know the adjacent side. So that's going to be a tangent problem. So tangent of our given angle, 26 degrees and 40 minutes, must equal the opposite over the adjacent. So x over 123. Set it up like a proportion, cross multiply, solve it for x. That gives me 1x equals 123 times the tangent of 26 degrees and 40 minutes. Type that in,
61.77.
and we get
61.77.
61.77292175. How come I can't round yet? Is that my final answer?
Nope.
That is not my final answer. My final answer is that amount plus what?
55.
That plus 5.3. So I have to add 5.30 to it. And then I'm allowed to round the height of that flagpole to 3 significant digits. So tell me what that adds up to.
67.1.
67.1? Okay. So we added it together, we rounded to the 3rd significant digit, which rounded up to 1, right? Okay. Feet. Be sure you put your units on.
Do not put inches.
Any questions about that? All right, let's break right there, and you guys can take a couple of minutes.